Hello friends, welcome to SR Physics Academy. Today we are going to discuss about mechanical properties of solid. In this video, we will learn about Hooke's law and modulus of elasticity. In the last class, we studied about what is elasticity and plasticity. Elasticity is the property of a body to recover its original configuration when you remove the deforming force. So what is plastic bodies? Plastic bodies do not show a tendency to recover to their original configuration when you remove the deforming force. So here, what is elastic limit? Okay. So elasticity means what? Ability to regain original shape and size of a material. So here elastic limit. Here I am taken here spring and rubber band. In this case, elastic limit, the limit up to which the body regain its original dimension after the removal of external force. So let us discuss with the example. An example here, if a small load is suspended from a wire, its length increases. When the load is removed, they regain its original length. Okay. But if a sufficiently large force is suspended from a wire, it is found that the wire does not regain its original length after the load is removed. So what is the difference here? Once a small rod is suspended from a wire, what happens? The length is increases. Then again the load is removed, they regain its original length. But the large force is suspended from the wire, here that does not regain its original length after the load is removed. That means the maximum stress within which the body regains its original size and shape after the removal of deforming force is called elastic limit. So here what is elastic limit? Means the limit up to which the body regain its original dimension after the removal of external force. Okay, is it clear? If the deforming force exceeds the elastic limit, okay, the deforming force exceeds the elastic limit, the body occurs a permanent set or deformation and is said to be overstrained. So, it is the overstrain. What happened here? That means here the deforming force exceeds the elastic limit. Okay, so then the body gets the permanent set. Permanent set means it can't come original shape. So here what is Hooke's law? So in this case, Hooke's law states that the force required to compress or stretch the spring, okay, whether the compress or stretch the spring is proportional to the distance with which the spring is deformed. It's named after British physics scientist Robert Hooke. He performed a number of experiments to observe the relation between the force applied to a spring and its elasticity. Here we know that, okay, when the elastic materials are stretched, the atom and molecules deform until the stress is applied. When the stress is removed, they return to their original, that means initial state. So here mathematically we can say that Hooke's law, F equal to minus Kx. Here F is restoring force of a spring and K is spring constant, X is displacement of the spring. So Hooke's law mathematically F equal to minus Kx. So it is used as a fundamental principle behind nanometer. Okay, here what is nanometer? A nanometer is a device to measure and indicate the pressure of a liquid. Next we can use here Hooke's law application, spring scale, the balance wheel, okay, the balance wheel of the clock and recoil of a toy gun. What is here recoil of a toy gun? The toy gun consists of a spring attached to its back. Okay. So when the trigger of a toy gun is pressed, what happens here? It releases the toy bullet and quickly get recoiled with the help of a spring, okay, attached to its base. So this action of recoiling is based on Hooke's law. Hooke's law states that the force required to extend or compress a spring by some distance is directly proportional to that distance. The stiffness of a spring is a constant factor characteristics. The property of elasticity states that it takes twice the much force to stretch a spring twice as long. So this linear dependence of displacement on stretching is known as Hooke's law. This law is named after 17th century the British physicist Robert Hooke. So that how the Hooke's law, the after scientist, his name is Robert Hooke. So here in 1807 Thomas Young pointed out that the strain is proportional to the extension of the wire and the stress is proportional to the load applied. So he modified the Hooke's law to the more general form as follows here. It says that the amount of stress we apply on any object is equal to the amount of strain is observed. So on in which means that the stress is directly proportional to strain. Here the stress and strain take different form of different situations. So generally we can say that for small deformation the stress and strain are proportional to each other and is also known as Hooke's law. So now we can say stress equal to, because after removing the proportionality we can say some constant will come. So stress equal to constant into strain. So if we want to the constant value, then stress by strain equal to constant. The constant of proportionality is called, the constant of proportionality, what you call modulus of elasticity or coefficient of elasticity of the material. So how we will discuss with the figure here. The figure shows the stable condition of the spring. Okay, stable condition of the means with here no load is applied. So here the condition of the spring when elongated to an, suppose the amount of that is some amount of x here under the load, how much here, suppose 1 Newton. Okay, we can take it, this coil it is 1 Newton, this is 2 Newtons. So here 1 Newton, the condition of the spring elongated to how much it is coming, the condition of elongated, suppose here 1 Newton we got it the x value here, okay, x distance. And the condition of the spring elongated to here 2x under the influence of load, how much, 2 Newton. Okay. So here the depending on the material, different spring will have different spring constant. So which can be calculated. So when we are calculating here the different constraint we will get, that depends upon the different materials. So the figure shows here 3 instances, okay, 1, 2, 3 instances. The stable condition of the spring, the first one is we can say that stable condition of the spring. The spring elongated an amount x under the load of how much? It is 1 Newton. Okay. This is 1 Newton. We are getting the how much distance? X distance. Maybe 2 centimeter or 3 centimeter. How much it is there? Next is, and the spring elongated to here 2x, okay, 2s under the load of 2 Newton. If we substitute these values in the Hooke's law equation, so we get the spring constant for the material in considerations. Okay. Now it's clear now how to calculate the strain or constant values here. Next is modulus of elasticity. So here what is modulus of elasticity? The modulus of elasticity or coefficient of elasticity of a body is defined as the ratio of stress to the corresponding strain within the elastic limit. That is very important. Okay, the ratio of stress to the corresponding strain within the elastic limit. So we can say that the modulus of elasticity, the letter is capital E. E equal to stress by strain. Clear now? That means nothing but modulus of elasticity. Here the SI unit of modulus of elasticity, Newton per meter square, and its dimensions are ml minus 1 t minus 2. Now we can discuss about different types of moduli of elasticity. Corresponding to the three types of strain, we have three important modulus of elasticity. The last class we discussed about what is strain and what are the types of strain. So first one here, Young's modulus. So the Young's modulus, the letter we use capital Y, the modulus of elasticity of length. So here the Young's modulus means what? We can calculate the elasticity of length of modulus. So that means the modulus of elasticity of length. Next is bulk modulus. Okay, bulk modulus is nothing but the volume. So here bulk modulus K equal to the modulus of elasticity of volume. And modulus of rigidity or shear modulus, this letter we can say that eta. Okay, eta, that is the modulus of elasticity of shape. Hope you understood. Thanks for watching.